Hello friends, today we're working on converting decimal fractional numbers to base 10 using the repeated multiplication method. In the previous exposition, we worked on how to convert decimal fractional numbers to base 10 using the expansion method. So today we're going to be looking at a far simpler method known as the repeated multiplication method. But don't forget, we are still working on the decimal fractions. So quickly, these are the things we must have to understand today's exposition. So the first is the basic knowledge of number base is very important. You understand this. The next is basic knowledge of fractions. You have to understand fractions, very, very important. The next is basic knowledge of multiplication and addition of numbers, very, very important. It looks trivial, but it's very, very important. You must have that. The next is 100% concentration. So now you have to know this. Now you have to always end it all with the base. Now, whenever you're converting to base 10 decimal fractional numbers using the repeated multiplication method, which I call the RMM, you have to end everything you're doing with the base. Everything ends with the base. Either the last number, either you solve that, with the last number or not, you just have to end it all with the very base. So this is an example. Convert 0.121 base 3 to base 10. Now, how do we do this? The first thing you do is to write this down, 0.121 base 3. Now, don't forget this. This is not like the expansion method. You don't need the number line knowledge here to try or to do well. So what just have to do, the question, you have to ask yourself a question. Where is the point? The point is here. The closest number is 1, so the point is here. So if the point is here, you will start from the other side. Unlike the whole numbers, for the whole numbers, you start from the other end. So since the point is here, you will not start with 1. You will start from the other end. And this time around, this base is not going to be seen as a base. It's not going to be seen as a whole number. You address this base as a fraction. So you're going to start from the back. So it's going to be 1 times, not just 1 times 3 this time around, 1 times 1 over 3. So 1 times 1 over 3, very important to understand fractions. 1 times 1 is 1 over 3. Don't forget this method, you have to times, add, times, add, times, add, and so on and so forth. But at the end of the day, you have to end it up with the base. So 1 times 1 over 3 is 1 over 3. Then I'm done with that. So the next thing I will add 1 over 3 plus 2. 1 over 3 plus 2. So LCM of 3 and 1 is 3. So 3 times 1 over 3 is 1. Plus 3 times 2 over 1 is 6. 1 plus 6 is 7. 7 over 3. So the times we add, and the next thing we are doing now is to times again. 7 over 3 times the base. Don't forget, you're not going to be using the base the way it is. These are decimal fractions, so the base will come in form of fraction also. So 7 over 3 times 1 over 3, that will give me 7 over 9. Then after times, the next thing we do is to add up. So 7 over 9 plus the next number plus 1. 7 over 9 plus 1. LCM of 9 and 1 is 9. 9 times 7 over 9 is 7. 9 times 1 over 1 is 9. 7 plus 9 is 16 over 9. Now, on the norm, this should be the last now should do. But don't forget, according to the rule, you have to end it all with the base. It's very important. So the next thing I will do now is 16 over 9 times, what's the base? The base is base 3 times 1 over 3. 16 times 1, 16, 9 times 3, 27. There's the final answer, and these are the right in base 10 decimal fractional numbers using the RMM. So quickly, let's see another example. Quickly, very, very important. Let's see another example. Number 2, write this, write 0.2234 base 5 in base 10. Write 0.234 base 5 in base 10. Now, how do you write 0.234 base 5 in base 10? It's very simple. Now, I write it out, just 0.234. Don't forget the process. This is where the point is, so I will start from the other end. So I'll start with 4. Now, don't forget 4 times 1 over 5. 4 times 1 over 5 is 4 over 5. And after that, after times, I will add together 3 plus 4 over 5. LCM of 1 and 5 is 5. 5 times 3 over 1 is 15. 5 times 4 over 5 is 4. 15 plus 4 is 19 over 5. So 19 over 5. The next thing we do after adding, the next thing we do is to times 19 over 5. Times it with the base times 1 over 5. 19 times 1 is 19. 9 times 1 is 19. 5 times 5 is 25. We've used 3 already. So the next thing after times, the next thing we do is to add up 19 over 25 plus 3. LCM of 25 and 1 is 25. 25 times 19 over 25, we are going to have 19 left. 25 times 2 over 1 is 50. 19 plus 50 is 69 over 25. So after adding, the next thing we do is to times 69 over 25 times 1 over 5. 69 times 1, 69. 25 times 5 is 125. Now don't forget, as we said, you have to end it all with the base. The base must be the final stuff, your final bus stop. So this is how to write in base 10 using RMM. So at this point, I'm very sure that you have what it takes to tackle this very set of questions for me. So these questions, you're going to take them home and work on them. The first, write 0.351 bases in base 10. Now you have to use your repeated multiplication method, not your expansion method this time around. Use your RMM. So the next is write 0.273 in octal, which is base 8, in base 10. So if you find this very exposition resourceful, subscribe to this very channel and share this very exposition. So see you in the next exposition. Bye for now.